Good morning, everyone. My name's Jon Bain, Principal Product Manager with Qube. And yeah, today we're going to kind of go over our product line with Qube and kind of future products, and then just how we're viewing the emissions space and what we think the future holds. So before I get going, I'll just get set up. All right. So just go over the agenda pretty briefly. So first thing we'll do is we'll go over our products, upcoming products. And then we'll jump into our platform. I'll do a quick demo, kind of showcasing how our products fit together, kind of go over our software platform and how it works. And then we'll jump back into the presentation. We have a nice case study to showcase how all the products fit together. And then we'll go to questions and answers. As Ben mentioned, please feel free to add questions into the chat during the meeting, but please refrain from asking questions during the presentation. We'll answer them at the end. So without further ado, we can get started. So first thing I just want to go over is kind of the emissions monitoring landscape and just how Qube is viewing that landscape and kind of the future. So from our point of view, we've kind of noticed the industry is trending more towards continuous data streams. A lot more data is coming in, but with data, that doesn't necessarily mean value. The key thing that the industry is trying to focus on now is operational insights. So less burden on operations teams trying to get that quantification information without adding extra work. So it's not just quantification for the sake of quantification. It's trying to get high efficiency insights on quantification and operational value. Additionally, more and more data is being found more useful as the literature finds that single snapshots through time are just not sufficient. So it's more data, but without extra burden. So just some key realities. Currently, there's no one-size-fits-all product. If there was, the industry would have circled on it. Every vendor or operator has their own kind of business needs. Snapshots miss intermittent emissions. So as more and more study is taking place on emissions, it's finding that emissions are not all the same. They're not just continuous through time. They have all their own separate fingerprints and different behaviors. So just a few snapshots in a year can miss a lot of context on emissions. And then, as I mentioned, every operator has various maturities and needs for emissions monitoring. So some are just wanting to do detection and repair. Others want quantification on top of that. And then others are aiming for a regulatory compliant program. And again, various products are needed to suit all of those needs. And then lastly, there's still persistent operational challenges and efficiencies, as I mentioned. So we're getting overloads of data these days to operations. And without context on that data, it can just be a lot. It can be a burden to just sift through it and find insights. So without proper operational context, this can just result in operational burden and workload. Especially for remote sites, this can be what we call increased windshield time. So it's just more time driving to remote sites, confirming if an emission happened, and just operational inefficiencies. So for Qube, how are we trying to tackle this? So our focus is going to be kind of four key areas. The first is we want to develop modular products. The main thing here is products that can stand alone or work together, and then they can be mixed and matched by site, use case, or budget to suit the client's needs. Additionally, as I mentioned, continuous data is critical, so we want to improve real-time and remote monitoring. Again, moving away from snapshots and trying to drive quick responses, data through time, and covering that temporal aspect of emissions monitoring. But with that, all that data, as I mentioned, you need high-value insights. So we want to use that data to deliver high-value, fast, and actionable insights to operations. And the goal here is obviously, as I mentioned, to reduce those site visits, reduce the operational workload. So that's all nice in theory, but how is Qube going to do it? So I'll jump into our products. First is our core product line. It's our Qube fence line. This would be the product that most people are familiar with. This is our most established and deployed product in the field. And it's our fixed fence line system that provides standalone quantification and localization. You can see it on the left there. These are continuous gas detection and quantification devices. They use CH4 sensing, but they can also sense other gases as needed. They use integrated meteorological sensors, so they measure wind, temperature, pressure, humidity, And it's that variable, that data that feeds our quantification model and localization model. The devices are fully self-sufficient. They're solar powered and autonomous. And then the whole product, the model and the devices scored very well at METech 2025. So that was the experiment that was run by METech last year in the summer. We have a slide that kind of shows some results, but we did very well. We're quite proud of it. And then additionally, with how strong the product has been, it's been used to reach OGMP level 5, so gold standard for some clients. And then it's also regulatory certified for the EPA and AER in Canada. So again, core use case for this product is regulatory compliance, site level leak detection and quantification. And we usually recommend this as an ideal product for larger facilities and multi-well pads. So those METech 2025 results, I don't want to spend too much time on this. We have blog posts and a lot of other resources that dive deeper into this, but just at a high level, the three key things that we think help drive home the performance of the model is detection. Do you detect gas through time? So the METech 2025 results was over 3 months. It was a very challenged release. They did 0 to 20 kilogram per hour release rates, and they did at certain points in time 8 to 10 concurrent and simultaneous releases. So how we did on detection, we hit over that 3-month period, 98% of the time we had the correct detection. So that was either a true positive or a true negative. And that's what that bottom left graph shows. That's our breakdown of time through that 3 months. So detection is great, but you then need to be able to localize properly, which then feeds the quantification accuracy. So in the localization, we also scored very well. We had 97% localization to the group level. And then finally, on the quantification side of things, across that 0 to 20 kilogram per hour rates, we compared our estimations for those rates versus ground truth. And what you can see there in that graph on the bottom right, that's the distribution around the ground truth for our predictions. And then the blue dots are mean. And across the board from the 0 to 20 kilograms per hour, we were within 1 standard deviation of error. So again, really strong results. We have a lot more resources that dives deeper into this. So if you're interested in learning more of our 2025 METech performance, please just reach out to your Qube sales or customer service rep. All right, so new products. The other product that we've recently been marketing and deploying in the field now is our Qube Lights. Some of you might be familiar with this product. This is a source level continuous methane detection device. So this is intended to be put directly into your facility around high value or high critical release points. So key thing with this is it's a compact methane detector, so methane only. It does continuous monitoring, and it's intended to be deployed right at critical sources. So for that to be the case, it has to be intrinsically safe. So it's C1D1 rated. It's standalone and autonomous, so it's solar powered, and it's extremely low cost. So again, this device's primary use case is for tank venting or single well sites. So marginalized sites where maybe wouldn't make sense to put 4 Qube fence lines. This is where the Qube Light could shine as well. Now, again, it can be a standalone device for detection of just key sources, or it can be paired with our Qube fence line, which we're currently in the process of rolling out a model that will utilize both the Qube Light and the fence line for quantification and localization. Our next product is our Qube camera. So this is a relatively new product that we just come out with. The key thing on this camera, it's a non-OGI, non-thermal. It's a visual detection only camera. And the main purpose for this camera is to provide visual context across your site, identify activity and events going on at your site. So it's an HD camera, 1080p resolution. It can do periodic scheduled events or event-triggered capture. It has an AI model that can detect certain objects of interest. So that could be personnel, vehicles, flaring, and so forth. And the key focus for this is it's standalone, solar powered, so it can be deployed anywhere on your site very quickly and easily. And the main use case for it is obviously monitoring your site activity. So any access, flaring, trucks, personnel, truck out. But it also pairs well with our emissions detection products, and it can help provide that additional context to emissions or what was going on at a site during a big emission. And we have some examples that kind of show this. And then lastly, this is a very new product that we're in the process of developing. I don't think we've marketed much on this at all, but we're in the process of developing Qube IoT sensor network. So these would be very low cost process sensors that can be installed at remote sites and enable remote SCADA-like monitoring through a cellular gateway. Now, the main driver for developing this kind of product is we see a lot of value in understanding the process data for the lead up to, say, a release event. Understanding what happened before a release happened can provide so much context to an event. And especially at marginalized or remote sites that don't have much instrumentation, it may not make economic sense to install traditional instrumentation. And that's where these kind of sensors can come into play. They're very low cost, and they can provide near continuous process data. So these sensors, we're going to be focusing on pressure, temperature, level, and vibration to start. They're intrinsically safe, so they're C1, D1 rated. The communication is Bluetooth between the sensors and the gateway uses cellular to the cloud. Multiple sensors can be connected to each gateway. And then this data would integrate with the Qube platform, can be visualized in the platform or pulled via export or API. And then further down the road, the gateway is compatible with several other communication types and sensors. So it's not limited to those four we mentioned, but it can communicate with Bluetooth, Modbus, UART, I2C, or digital analog. So a lot of opportunity to connect with various types of sensors. And the way we view this core use case, again, as I mentioned, it would be those marginalized assets where traditional instrumentation is not cost effective. And then these things can monitor your tanks, compressors, pumps, your wells, and then focus on monitoring equipment run status, normal operation, and then especially venting. Pressure is a great indicator for releases or venting, so it can be a great tool to try and provide indication of a vent going off. Okay, so the next thing I'd like to jump into is our platform. So I'd like to showcase a couple examples in our platform of how our products work. So this is our demo environment. What I want to go over first, I'm sure some people might not be familiar with our site dashboard, so I'll do just a quick overview of our site dashboard, and then I'll jump into an example that showcases the Qube light and the fence line together. So this is a test facility. This is a real natural gas facility that's allowed us to deploy our products and test their performance. So what you'll see here on the site dashboard, the first thing whenever you come into our platform is you'll see a map in the top left corner. That map will have a drone image overview of your site. And then on that image, we overlay sources and our devices. So the sources are these black dots, and you can see the black dots all over this site. These are the sources that we've identified. And then the colored icons are the Qube devices. Now, there's a lot of Qube devices. This wouldn't be typical for deployment, but we've put so many on this site just for the testing purposes with this test facility. On the map, you can see these icons on the top left. These are really just icons that allow you to improve the visualization of the site. So for sources, I can toggle on kind of source icons to see what types of sources. So these are all tanks. These ones down at the south are compressors, and these are separators and so forth. And then I can also toggle on device labels. So specifically, if I'm looking for a particular device, I can toggle these on and off. Devices specifically, the circular devices are our Qube fence line. If I zoom in on our tanks, the square ones are our Qube lights. And then the triangular ones that you see here are the cameras. If I hover on the camera, you can kind of see the field of view that pokes out at the end of the triangle. On the site dashboard, the key feature is you can pick a timeline view, so you can set the time range, and then that'll kind of set the emissions data that you're visualizing for that time period selected. So you can pick any time range for the site, and it'll filter and show all the emissions data for that period. For this example specifically, I'm focused on December 13th. And then once you pick the time range, the visuals on the bottom left underneath the map are our time series charts, which will then update for the time range selected. So this first widget that you see here, this is what we call our timeline. This visualizes key events at the site and is a more rolled up view of things that are going on at the site. So the first thing you'll see on this timeline is an event. So we allow users to create user-created events at your site. This allows you to just create a start and end time that you want, add a title, and add comments. So you can add your own context to your timeline. And this example, we just added an event called a event thief hatch pop, a time frame, and then a comment about why that thief hatch popped. The next thing that you can also add in are third-party inspections. So for this site specifically, we have an aerial inspection, which is shown by this blue dot. And if I hover over it, you can see the plume that was provided by the aerial provider. So you can upload your aerial inspections, your KMZ files, or their images, and we can overlay and show them on the platform. So you can persist that or toggle it off. You can also go in and edit the details of that emission. And then lastly, we have the emissions. This is the output of our quantification model. Anytime there's a detection, we create an emission event, and then those time-bounded events can be summarized and rolled up into kind of this timeline view. Underneath that, we have these buttons that allow you to toggle on more time series views. If you have a fence line product, you could toggle on the CH4 rate. So this is the quantification model output through time, and with various averaging periods that you can view the data. Then we also have the raw data for the devices. So I'm showing the Qube Lite CH4 because that's the example we'll go into, but you can toggle on the CH4 for the fence line. You can see the actual raw data that was detected through time. Same with the Qube Lites. And then any of the other gas sensors that are installed on the device, you can toggle them on. Then lastly, you can also see device battery, wind direction, and wind speed from the fence line devices. And then on the right side, I'll just toggle these off real quick. On the right side, we have kind of rolled up widgets that show the summarized emissions performance through time. So the first is our emissions by month. This is your total emissions by month for the site. Because this is a demo environment, we only have 1 month shown, but normally you would be able to move through time and see your other emissions volumes per month. We have an emissions versus baseline widget. Again, if you set a baseline for a site, which is what we always recommend, this would show you the performance of your emissions relative to baseline for the time period selected. And then lastly, we have an emissions rolled up kind of summary table, which groups your emissions by source groups, so tanks versus separators, compressors, and so forth, specific sources, and then just a list of your emissions. And then lastly, we have the event log. This is essentially this event timeline down here, but shown in tabular format, where you can see the specific events. You can come in, open, and see them. You can edit, change the events. You can add a new event in here if you want. Inspections as well. You can come in and see your inspections. You can edit your inspections, and you can add new inspections. So you can add a new aerial. You can load a KMZ file or manually add an aerial inspection with all the information in the plume and upload your aerial image, or you can add survey inspections, OGI or ABOs. You can add details on it, whether a detection was found, and add an Excel file. So that's the overview of the site dashboard. I know that's quite a bit, but if you'd like to get more info, again, you can always reach out to your Qube customer service rep. So now I'd like to just dive into a specific detection scenario at the site. So the example I'm focusing on is there was a release from the tank farm, specifically this kind of red emission event. And what I want to show is if you were using the Qube Lites on their own, so obviously we have all of the detection technologies, but if you were using Qube Lite on its own, there's a release from the Northeast on these tanks. And we have several Qube Lites on the tank farm. So what you can see here from the Qube Lite PPM chart here, you can clearly see there is a pickup of concentration across the Qube Lites on the tank farm. Now, one of the key features we have on the visual on the top right is we can turn on this thing called concentration roses. So this allows us to turn on, kind of visualize the raw data of CH4 detection from the devices. And then the rings around the Qube Lite specifically show the concentration hits, and the magnitude is shown by the color. So what you can see here is during this time period, we had several detections on these kind of northeast corner Qube Lites. And the ppm concentration also aligns with that. Now, in this instance, we didn't have an alarm set up, but you are able to set up alerts on each Qube Light device based off concentration. So in this instance, if you had Qube Light only, you would have been able to alert on this ppm detection off the tank release, and we would have generated an alarm that could have sent a notification to your operations teams. Now, this would be ppm only, but again, this still would have captured the detection. And then with the concentration rows and us knowing which device picked it up, you would be able to pinpoint which tank was causing the leak. Now, zooming back out, I wanted to show how our fence line also performed in conjunction with it. So if I turn off our CH4 and turn on our fence line ppm, what you can see here is we also detected fence line concentration throughout. So this is the circular devices on the outside, the perimeter of the tank farm. They also picked up that release. And what you can see on the concentration roses here is on the fence lines, they show these triangular kind of circles around the devices, which indicates, one, the direction that they were getting concentration hits, and the size and color shows the magnitude. So one of the cool features from a UI standpoint that we enable is you can kind of hover on these and it projects the cone further down on the site. So if you what we usually do is we recommend you can click and toggle these on, and you can kind of toggle on the top cones from all the devices that had the hits, which were these Western devices. And you can kind of see where all the cones overlap. That's typically where we're going to localize to. So the cool thing is if we turn on the heat map, which is another feature we have at the top right, this visualizes on the site where the emissions were localized to. And you can see that's exactly what happened. We localized to this tank 2 with our quantification model. So fence line on its own as well was able to detect the event, same as the Qube Lights, and it quantified and localized to the exact same location as well. So both products completely standalone were able to quantify and localize to the tank farm. So again, these can be paired together or standalone to suit your needs. The fence line has the quantification and localization model, whereas the Qube Lights have the ppm only alerts. Again, we will have a model soon that will combine the two together. And then one last thing I wanted to show off is just this additional feature we have. It's called our simulated plume. So if you want to understand kind of how the model was working, these devices on the west were getting hit. So clearly the wind was pushing to the west there. So we can simulate the plume of this emission, and then it can visualize when you hover over it what the plume or what the model believes the plume was doing off of the tank through time. So this is a great way to help you understand and visualize what the model was thinking. And again, if I toggle on that inspection from aerial from the flyover, it lines up quite well with that plume. So again, we just think all of these features combined together helps give a really, really great context to the operational team to understand what the Qube model was doing and what we think was going on at the site. And again, two different products detecting the same thing. So we think that's a really great example, showcases how the Qube Lights on their own can work, how the fence line on its own can work, and then how they all work together in conjunction in the platform. The next feature I want to go over, or example, is I want to go over an example of our camera. So in this example, I want to zoom in on the tank battery again, or tank farm. So in this example, we have 3 emission events that you can see in our timeline. So these emission events were all localized with the heat map showing as tank 4 to the west of the tank farm. Now, when we talked with their operations teams, there was no clear process data or indication that there would be an emission from tank 4 or from the tank farm. So we were kind of stumped on what was causing the emissions. Now, what we always say, though, is we detect very well. So if there is concentration hits in detection, there is something going on at the site. So we needed additional context. And that's kind of where the camera came in extremely handy in this example. So if you have cameras installed at your sites, again, these triangular devices on the map, you'll have this button available to toggle on the camera timeline. So if I toggle on the camera timeline, you'll see this series, which shows a row per camera. So this site has 5 cameras, and each dot is an image taken by the cameras. As I mentioned, we can program the cameras for just a routine scheduled image. And then they also do exception-based detection based off objects of interest. So what you can see here is the spaced out dots, those are scheduled. And then the more concentrated dots are where we have periods of interest based off of object detection. Now, if you hover on the camera, depending on which one you're on, you'll get this view of the images from the cameras through time. And if you just slide across, you get the updated images. You can also click on the timeline and it'll pull up the camera that you were on. And then you can get a more blown up view of the images, which you can then go forward and backwards through time. Now, specifically in this instance, this is a lot of images to go through. So you can filter to kind of events of interest. And then you can kind of see hovering over it, it brings to the forefront those images that meet that criteria. So in our example, what I'm focused on and what stands out to me is I want to focus on the vehicles. So hovering on this, I can click on that to persist that view. And the first thing that stands out to me in this example is the light blue camera, which is right here looking at the tank farm. And then the second thing that stands out is all of the images from the light blue camera seem to align with those emission events. So when I hover over this, the first thing that stands out is there was a truck during every single one of these emission events. So if I hover over this one, another truck. So you can see the model is identifying it as a vehicle. There's clearly a truck at the truck out. And then similarly for this much longer event, you'll have to bear with me. My computer can be a bit slow, but there's another truck. So this additional context from the camera allowed us to relay that info to operations, which allowed them to identify that there was a small vent tank to the east of tank 4 that relieved during truck out. I had no process data on it, no indication, really no way of knowing if it was venting or not. But it allowed us to identify that there was in fact venting going on during the truck outs, and the camera was able to add that extra context for us to understand where these emissions were coming from. So again, we think this is a great example. Again, the cameras on their own could be standalone to just indicate when you're having trucks arrive at your site or when there's vehicles or access occurring at your site. But again, when paired with the emissions data, it can add that extra bit of context to explain why there are 3 emission events that were previously unexplainable. So that's it for our platform demo. I'd like to now jump back into the presentation and kind of go over a case study that ties this all together. So again, this is another example from this test facility. And this one combines kind of all of our data plus process data at their site. So this is an upstream natural gas processing facility. We have the 3 core products deployed, so the fence line, Qube light, Qube camera. And at this site, the example that we're going to go over, it's a slugging event that happens at the plant. For those that aren't familiar with a slug is a plug of liquid that can come into the inlet of a plant. So typically you have gas and liquid flowing together in the inlet. Eventually you can sometimes get a large just plug of pure liquid that hits a plant. These can be very hydraulically significant to a plant and cause a major upset. The extra liquid can cause a lot of liquid flow into the tanks, which can cause extra vapor and then potential venting and flaring. And that's exactly what we see in this example. So they experience a slugging event from 1 a.m. to 1 p.m., and then they experience tank farm venting and flaring. And then what we want to focus on in this case study is the detection and response. So we were able to capture the full event timeline. We used their process SCADA data to provide root cause insight into what caused the event, and we were able to diagnose and troubleshoot the event fully remotely. Now, the reason we really like this case study is it hits on, again, why we're focused on those Qube IoT sensors, why we think process data is so important, is understanding the lead up to that event, understanding the process events, and that fingerprint of the event can help add so much context to an event like the release and what we quantify. And this just really hammers home the ability to take all of that information and define an event without needing to talk to operations and doing it fully remotely. So the first thing I want to go over is kind of that process signal. So again, every kind of major event at a plant, there's so much process data and SCADA data that can give you information. The key challenge is understanding what variables to look at to give you that information. And I would call this kind of like the fingerprint of the event. Most of these events, if they reoccur, you would see kind of the same signal in the data. So for this specific example, to define the slugging event, we focused on 4 key process variables. The first item is the inlet separator water level. So with a slug of liquid coming into a plant, you're going to get a lot more extra liquid and water into the plant. So you'll see that in the inlet separator water level with how frequently it dumps and just how unstable it can become. The next item, extra vapors getting into the tank farm from the separator will feed the VRU suction pressure. So every tank farm has a vapor recovery unit. And if excess vapors get into that unit, its suction pressure can change or become unsteady. So monitoring that can be very helpful. And then next, gas plants are designed to kind of last line of defense is to relieve any excess vapors or pressure to the flare system. And that's usually an indication of a plant upset. A very large slugging event would typically result in a plant upset, and you can monitor the flare flow to see if that's occurring. And then lastly, a slug is a very hydraulically significant event. It can block off gas flow to the plant and cause major pressure swings. So a gas plant should run with pretty steady pressure profiles throughout. So monitoring the inlet separator pressure is a great indicator of plant upset or a big slug. So those are the 4 variables that I want to focus on, and now I'll run you through kind of a sequence of events of how to read the signal from these 4 to indicate a slug. So the first phase for the slug is you'll see increased liquid load and vapors to the tank farm. So a slug doesn't just hit a plant right away. A slug will build up in the pipeline and lead to increased liquid flow into the plant. And that's kind of what you see in the inlet separator water level. So you see in that variable, you see a very high frequency of spikes. That's kind of the level building up and then dumping. If you compare that to the frequency to the right side of that trend, you can see a much, much higher amount of liquid coming into the plant than under normal operation. Now, as that liquid is dumping to the tank farm, that's going to result in more vapors to the tank farm. And eventually those vapors will get to the VRU, which can cause an overload of the VRU, which you'll start to see that pressure start to build and become unsteady. So in phase 1, you kind of see it pretty stable around its set point, but it starts to deviate away from that near the end of phase 1. In kind of phase 2, those vapors start to overload the VRU, and you see the VRU suction pressure become unstable. So it's no longer hovering around its set point. And then eventually those vapors in that tank farm start to overload the system, and then they get relief to flare, which you start to see in the flare flow. You start to see the flare starting to pick up. Finally, in the third phase, the full slug hits the plant. This is clearly indicated by the inlet separator water level. You can see just the frequency is almost all blended together. The level even steps up. So the separator is really struggling to keep up with the liquid going into it. The VRU suction pressure continues to remain unstable, and then you can clearly see a very large spike in flow to the flare. So that's a very big upset at that point. And then the biggest indicator too is the inlet separator pressure. You see during this phase, the pressure becomes very unstable as the plant tries to line out and control the intermittent gas flow that's coming into the plant. So very unstable, major upset during this period. And then finally, in step 4, the slug passes, the plant starts to get it under control, and then the process control system stabilizes out. So you see after about 12 p.m., 2 p.m., all of these variables kind of line back out and reach their kind of set points and become normal again. So this slide, I would say, is a perfect example of kind of the fingerprint of a slug. So if this event were to reoccur at the plant, you would likely see these exact same signals across these variables. So this right here gives us kind of the context of the event, what happened. There's no guarantee that there's necessarily venting, but we can start to kind of correlate what would maybe be the timeline of potential venting. So in this example, we like to use the VRU suction pressure as a good proxy. The VRU suction pressure becoming unstable clearly indicates vapors in the tank farm. So that could clearly indicate a period where there may be venting. So just kind of time bucketing the period where the suction pressure becomes unstable, which I've highlighted in blue, is the likely period of tank venting, and we can use that to compare against the Qube detection data to see how Qube did. So first, the first thing we'd want to look at would be the tank top Qube lights. They're the first line of defense. And what you can see from the concentration, this is directly from the platform. The tank top Qube light ppm aligns almost perfectly with the VRU suction pressure and stability. So clearly there was venting during this period, and the Qube lights were picking it up. Specifically to the slugging happened around 6 a.m., just after 6 a.m., and that's where we see the highest concentrations off the top. So that would be during the period of the highest instability and highest vapors in the tank farm. Secondly, as that plume off the tank farm disperses away from the tank farm, it would hit the fence line devices. So what we see on the fence line devices is exactly that. We see a little delay, but then we see spikes across all of the fence lines around the tank farm. So again, perfectly aligned in the time frame of the VRU suction pressure. And then obviously our fence line is the devices that run the quantification model. So that model ran, and you can see in the image on the top right, we look at the tank farm, the correct tank. You can see just from the concentration roses, and it's a bit hard to see the heat map underneath it, but it localized to the top right of the tank farm. And then it quantified the rate, which you can see in the bottom chart. Again, that rate is shifted 1 hour off because it's a rolling 1 hour average, but it properly captures the time period of the event and quantified to about 8 to 10 kilograms per hour. So again, full detection and quantification throughout the period of venting. And then lastly, we had a camera focused on the flare. Throughout that whole period where the flare flow was going, that camera detected flaring events, which you can see in the image below, which is an image directly from our cameras. So we really like this example. We think the beauty in this example is using the process data, we were able to fully define the event, what was happening at the plant. We were able to predict when we thought there'd be emissions, and then the detection data captured those emissions for that time period. And then we've had visual confirmation with our camera. Obviously, this is a fully manned site. So they would have been able to have this information themselves, but you could see the value of this at a more remote site where having this context relayed remotely could prevent potentially a site visit or field visit from an operator. And this is why we're so interested in trying to get more coverage of process data to get that upstream context of what led to an event. And then it's not a stretch to believe if you have all of that information, that event fingerprint, you could potentially automate those insights. So this was obviously reviewed and analyzed by myself, but you could absolutely see this being done automated and being sent through AI. So why does this matter? So in our view, this provides greater insights in one platform. As I mentioned, it provides full event visibility. You go from deviation from your process to the eventual release and then stabilization. Emissions are accurately localized, quantified, and correlated to the process data. And then that process data helps us identify the root cause remotely. And ideally, this results in no on-site troubleshooting required. And then, as I mentioned, having all of this data and context opens the door for the foundation for automated insights. So identifying event fingerprints and then having automated and smarter and proactive alerts that can flag based off of that event context. So in conclusion, just to kind of summarize, Qube, we're really focused on building modular products, and we really want to focus on that operational value and emission insight, not just quantification. We want our products to be deployable standalone, so depending on your needs, you can use one product if you want, or combined for a better suite of solutions. The goal here, obviously, is with this suite of products, we enable flexible deployment. So it's aligned based off of your site size, complexity, or budget. We right-size the coverage without unnecessary instrumentation, so we don't have to over-deploy instruments on your sites. And then the goal here, obviously, as I mentioned, greater operational context in a single platform, and ideally driving real-time, clearer decisions with fewer site visits for your team and less operational workload.